Interactive Statistics Methods, Chapter 10, is on parametric and non-parametric measures. So this is when we wrap up everything that you've been learning thus far. We're going to talk about how research designs are put together, give you some samples of how that data is acquired, how you go about determining critical values, and in preparation for hypothesis testing, a little bit of that here, but mostly so that you have an understanding of how you calculate these various statistical measures. So again, we have our add icon at the beginning and research design terminology. So this beginning of the chapter is critical. It's really going to talk to you about the variance as a measurement of area, standard deviation extracted from the variance, and how the variance can be used in particular in measures such as ANOVA, analysis of variance looking at multiple groups, ANCOVA, analysis of covariance, multiple groups with pre-test and post-testing, multivariate analysis of variance with multiple groups over time with multiple tests, pre, post, different types of tests, and how all of that can be measured to determine whether or not you have enough evidence to reject the null hypothesis and therefore accept the alternative hypothesis, which is your true research hypothesis, and show that you have enough inferential data to infer back to the population from the sample. So that in a nutshell explains all of that. When you read that, that's going to take us back to that earlier arena when we talked about statistics being a portion once again of research design. Reliability, validity, and in effect objectivity. So reliability, consistency; validity, truthfulness; and objectivity, the lack of bias on the part of the researcher or any type of bias that you can weed out so that the study is really reporting what it's purported to measure without any type of interference by extraneous factors or the researcher themselves, or even in many cases the presence of the researcher. And we know that's critically important because in the social and behavioral sciences we're dealing with human beings and the effect that they have, such as the Pygmalion effect, Hawthorne effect, some of those discussed in this particular chapter, that kind of occur when they know that they're under a watchful eye, they're being studied. So you really want to determine whether the actual variables that are under study are actually causing or are what you're really studying when you are conducting a research design, because anything that is going to make your research invalid means that the study has no place in the body of knowledge. So you want to be aware of that. And there are types of reliability, validity. All of that is talking here. What is construct validity in terms of sound theories that back a particular research design? Concurrent validity. Does the test measure truthfully, validly what is purported to measure? Content validity. So do the items on the test correspond to whatever it is that you're measuring? External validity, where the truthfulness applies to other subjects and situations. Face validity. There's a lot of them. Internal validity. So as you begin to read about these types of validity, just like your types of variables, and we know, of course, with our scales of measurement, that's going to determine what your research design is going to be. True experimental designs having a control and a treatment, determining how that's going to play into human subject designs. And I should say that here, we know that a lot of our protocols in traditional research have to be adapted because human beings cannot be put in the petri dish, and that's why it's important to be aware of human factors and such things as IRB, institutional review boards, which will help you from violating the law when it comes to dealing with human subjects. So you have to be very aware of all of these principles and practices when you're going about putting together your study. So going back to your initial research design. So we come full circle at this point. Looking at sample methods and sampling methodology. How do you extract that sample? There's many different types of sampling. True experimental research designs. We just talked about that with treatment and control groups to determine if some type of practice is effective. Quasi-experimental, all right? Looking at mixed methodologies, quantitative versus qualitative data, and we'll deal with that a little bit later on. Terms such as a priori versus a posteriori when we're dealing with looking at research designs that are critical when we're talking about looking at what was present before you begin your research and what's available after the observation has been made versus a posteriori, which is following after that. And then that gets into post hoc testing after you've got a significant level of significance. So some of that's here, jumped a little ahead, ad hoc, post hoc, some of these different things that apply to putting together a research design. Your effect size, your experimental research design that measures the strength of the relationship between variables. How do you go about putting that together? Estimation, expected variables, the ability to generalize back to that population, external validity. We know, of course, our hypothesis, which we talked about at the beginning of the book, our educated guess, what the types are. The research versus the alternative hypothesis. What that looks like mathematically when we have a directional, greater than, less than. How do those apply? What does it look like when you put all of that together? Okay? And how does that apply to parsimony in terms of speaking simply and using succinctness, conciseness in reporting our research? Very important, okay? Understanding that and how these relationships break down. Now, in terms of non-parametric measures, this book primarily deals with the chi-squared test. In terms of parametric measures, looking at things such as correlational measures, or ANOVA group, and true experimental designs using Tukey's t-test or studentized t-test for independent and dependent group means. So looking at those various types. We talk about meta-analysis in terms of looking at the effect size of multiple volumes of research, which in and of itself, research on research. Meta, of course, being beyond. So beyond analysis on research. Metacognitive analysis, which is dealing with the ability to look at, through chi-square analysis, different areas where, such as the liberal arts, and different areas that cannot, where the functionality of a true experimental design will violate the protocols in that particular educational arena. So these are some of the things that we can look at. Okay? And there's objectivity there, psychometrics, actually testing, and then we get back to some of the things you saw before, scatter plot, sociometry, okay, and spiral testing stability. So reading this language, again, of statistics will better prepare you to understand statistical tests. Now, types of research studies, double-blind techniques, okay, which one of the variables under analysis, cross-sectional study, factor analysis, okay, looking at relationships between multiple variables, random effects, okay, semantic differential, Solomon four-group designs. And then the crux of this is getting down to our types of error. So being aware of rejecting the null hypothesis as false when it's true, which we want to avoid, which we know is our alpha error. And while we have the alpha, usually set at 20% or 0.05 for most researchers, and that's the likelihood of us rejecting the null hypothesis when it's actually true, because you can do that. And that's something we want to avoid. And the antithesis or opposite of that is a beta error. You're accepting the null hypothesis when it's actually false. So the ability to make certain that we're not making a mistake in the research, and we're looking at all the intra and external factors that could possibly inhibit the research and the research design from doing what we're trying to do, which is provide enough evidence to support our hypothesis and therefore reject a null hypothesis. And we talk about some of the types of bias in here to set the pattern for what we're going to be doing and how to make certain that we don't make those mistakes in our research. You have to be very careful. Errors in measurement, okay? Negative effects that can disturb your outcomes. All right? Effects, Rosenthal, Pygmalion, knowing what those are. All right? And tail tests. So when we start talking about tail tests, we're going back to our previous chapter. In chapter 9, we're talking about normality, looking at ends of the normal curve in terms of social science research. Okay? Being able to conduct analysis with the t-test. So we give a sample t-test here, how it's calculated, what the mathematical hypotheses look like if it's two-tailed. We'll have an equal and an unequal versus one mean being greater than the other mean, looking at populations of two groups, one mean, two mean, and what it is. So if we're able to provide enough evidence to show, and this is the null, that the means are not equal, then we can reject the null and therefore accept our can get that out, alternative hypothesis, and we're setting it at 0.05. So 20% chance of us having that type 1 error, which we want to avoid. There is our calculative statistic given after we've extracted there, and then you're given an experimental research design, how to calculate it, determine that down, do the calculations, find out what that critical value is, look up on page 440 in your book, there's a number of tables in there, you'll find the t-test, and at the critical value for the degrees of freedom for that t-test at that alpha level was determined to be 2.145. Our 5.69 is significantly greater than that. Therefore, we have enough evidence to go back and reject our null hypothesis here, boom, 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 and therefore accept our alternative hypothesis. Didn't go high enough with that boom. So that in a crux is the statistics and the statistical measuring calculations and how you go about that. Now, after the t-test, there's also a t-test value for the comparisons of two independent means in equal size groups. Okay, we show you what that is. Analysis for looking at multiple groups, and we show you how to do that in here. The correlation coefficient for looking at the strength of variables between a variable and x and y, and then a chi-square test. So we go further than just defining them here. Here's your sample of a research two-tailed problem for determining the relationship between, and you can see the situation read about here, and for correlation. Again, alpha 05. There is our actual calculation for that. There's our data we've extracted, our sample data. Go through, do the calculation once again. Determine that at negative 0.066, so we know that that definitely is a negative because your scale is between a -1 and a +1, with 0.5 being lower than that, higher than that on the negative side is strong negative, lower than that on the positive side is a strong, weak positive, higher than that strong positive, lower than that strong negative. So as we look at these particular things, we then have to take that R value, because it's not in an actual test. To look on the critical value table under R's are actually looking at, again, between -1 and 0, that strength of relationship. So what we have to do then is go ahead and convert that to a T, and you're negative 3.73. Therefore, you take the absolute value of that, and it's rejected at 0.5 versus that. So there's not enough evidence there to reject the hypothesis, because 3.73 is not greater than 3.0 or 9.2. So either at 0.1 or 1 out of 100 chance or 20 chance of making that type 1 error, it's just not, there's not enough to reject it. However, the research was looking at the strength of the relationship, but in terms of looking at it, there's not enough data. You have to have more data for a two-tailed test. Spearman's rank correlation coefficient is given you after you look at Pearson's, and you're given a sample there. Read through that. We talk a bit about regression analysis and simple linear and what it is. Post hoc tests, some of them such as Sheffey's 2 keys, honestly significant difference tests, Newman-Kuhl's pairwise tests, multiple range tests such as Duncan's, least significant difference from Fisher, and some of those other tests there that you would look at your research after you have a level of significance. Post hoc, which means after the fact, after that research has been conducted. And lastly, we come down to chi-square. So we talk about that, some of the other different types of tests, Mann, Whitney, Wilcoxon, Kruskal, Wallace. But we look at chi-square, and we give you a sample of that, how to actually do chi-square, what the studentized T is in this chapter. So this is a very detailed chapter explaining all of that to you. Read through it. Very, very careful. Take a look at this. Read it very, very careful. Go through it thoroughly. Take a look at it, because these are some of the main tests. You're given a lot of sample tests here and how to calculate them using statistics.